In the ongoing agent playlist series, one question has always arisen in the community. What is the difference between large language model and an agent? So let's understand this with an example. Consider the time is 7:30 p.m. Based on this timing, I ask a prompt to a large language model saying good morning. So the response is good morning, how can I assist you today? If you look at the response, you don't have any real-time data and LLM has a knowledge cutoff. So no matter what query you pass in, you get the relevant responses. If you look at agent's response to the good morning, it says good evening. It seems like it's still night time, but if you are greeting me with good morning, maybe you are preparing for a fresh start or a specific context. Let me know how I can assist you. If you look at this response, there are two things that is happening. First thing is it gets the real-time data from the environment. The environment can be your weather API, it can be Google search, it can be anything from where you are getting the context. So once you get the context, you are making a decision where you reason and you plan. So agent has the ability to do function calling along with decision making. This is what makes it different than a large language model. With that in mind, let's start with today's video. In this video, we will dive deep into advanced agents using LlamaIndex, where we will talk about language agent research, one of the cool agentic frameworks that has been implemented within the LlamaIndex library. In order to understand language agent research, you need to know what is React. I've already shared one detailed video on what React agent is. If you have not watched it, you can go watch that video after this video, of course. So here is a quick overview on how React agent works. You start with a simple question. So the simple query is nothing but a task that you are giving the agent to perform. Let's take the same example, good morning. Now based on the input good morning, agent needs to think what it needs to reply back. This is where if there is any action that it needs to take. By action, it can be set of tools that you have. And in our case, the set of tools was real-time search. So what it will do? Given the query, which is good morning, it will think and then it will take the action of what tools it needs to pick and how it needs to respond back to the user. And once it responds back, it gives you the response, which is observation. Here is where you are using an LLM to generate the response. And if in case the response meets the criteria, it will generate your results. You will check the goal. If it meets the goal, you have your final output. If not, it will again go think what it needs to reply back to the user, take the action, get the observation, and then give the response. So this thought, action, observation, the cycle of loop will repeat for multiple times until you have the better response. There are two ways you can stop it. One way is you can set a maximum iteration. Second, you can have certain output key. So if you get this kind of output, you just have to stop. You can fix the second option by writing a very good prompt and you will have your React agent in place. So now that you understand the thought, action, loop, repetition of React agent, let's move towards language agent research. Language agent research is used for reasoning, action, and planning, and it is based out of a very famous search algorithm called Monte Carlo Tree Search. In Monte Carlo Tree Search, it gathers enough information for the given user query, and based on that, it will decide which is the most promising moves that it needs to take once it has seen enough data. So, LATS also uses Monte Carlo Tree Search, and let's understand how it works. For the given user task, first you will initialize LATS, and here is where the Monte Carlo tree search will be triggered. And once you have the tree search algorithm ready, you will create a root node. So root node is the starting point of your language agent research. Now once you have your actual task, you will divide that actual task into multiple expansion. So this multiple expansion is your sub node. So now once you select any node and you expand it, each node will have its thought, action, observation. So it internally uses React framework to generate the response. So once you select a node, each node will have the execution step, which is using React, and then you have the evaluation of that action. So in evaluation of the action, you have language model, which is used as a value function to generate a scoring mechanism. So if in case it needs any additional environment, suppose if it needs to use any tools that the user has provided, then it will also have the environment from where it can get the context. So this is mainly used within the expand node and the evaluation action, which is pretty similar to what React will do. And once that is done, you will simulate the response, which is your observation. One thing what you need to do is,
how is the score calculated, right? Here is the formula for the score on how you have that value function score. You have a weight mechanism which is used for lambda, and then you have language model which is mainly generated through LLM that you have used to build the LATS framework. LM is nothing but language model score, and then you have self consistency score. So self consistency score is mainly calculated as number of majority outputs from the node divided by, just imagine there is a dividing line. You have total output, so your number of majority outputs by total outputs covered. So this is how self consistency score is calculated, which is the overall score, and then you are checking the value score for each node. If the score is higher, that means that node has the best solution that it needs to generate to the user. And since we are using Monte Carlo Tree Search and we are repeating multiple times, you also need to have a state management where you're saving the memory. So once you have your response back, you are updating the memory, and if in case the response was correct, as I said, simulate path until terminal state. So terminal state is nothing but the end state. If at this point of observation, if you have the right response, it will complete the task and it will return the solution. If not, again it will run the loop of evaluating your agent, which will think thought, action, observation, evaluate, and then again it will simulate the path. Then it will again update the memory. If in case you have the right response, it will generate the task complete. If not, it will repeat. So let's take an example to understand how this works. I have created one example. All right. So let's suppose you are doing any search which says which magazine started first. Okay. And then you have a root node. So root node is where Monte Carlo Tree Search will be triggered, which is your actual query. And based on this, now an agent will think what it needs to search and what action it needs to take. So it will create sub nodes. So in the first node, it will think search magazine A. Then in node 2, it will search magazine B. So it will take an action. It's same as React. Think, act, and observe. And once it gets the observation, you need to have an evaluate node which will calculate the scores based on the language model. It will give you the value calculation and then it will generate the formula. So here, what is this UCT? UCT is another formula which stands for upper confidence bond tree. So it's a formula which is used to generate the final result. And once you have the final node, it will give you the answer. So this is how LATS actually works, and we'll dive deep into the code implementation. If you are interested to know more, you can go check out the paper. The link is in the description. It's time for the code implementation.
Alright, let's implement language agent research using LlamaIndex and SambaNova AI. SambaNova Cloud is world's fastest inference engine that can give you responses for LLM in just few clicks. So let's proceed with the installation. We need to install few dependencies. We'll start off with pip install LlamaIndex agents LATS, which will get all the dependencies of LATS framework, that is language agent research. And then we need the LlamaIndex core. Since we are using SambaNova AI as our default LLM, we need to override the LLM which is already default in LlamaIndex, that is OpenAI. So then we need the function tool, which is DuckDuckGo. So this is mainly used for real-time query to get the real-time results. It's an external tool that we'll be using, external tool. And lastly, we'll be using LlamaIndex LLM SambaNova systems. So this is our LLM and we will use Meta Llama 3. Let's proceed with the code. The first step is you need to run the asynchronous apply. Since we are using collab, it might be chances that you will end up into event loop. So it's always better to add these 2 lines of code. And the next step is you need to set up your API key. Set up API key, and what I'll do is I'll just write import os dot environment SambaNova API key. So let's get our API key. In order to get your API key, open cloud.sambanova.ai. Once you open SambaNova AI, you will find this playground where you can enter your user query and get faster responses. And there are tons of models that you can choose. What we need is we need the API key. In order to get your API key, click on API, generate new API key, and you have your API key ready.
and the model name here is MetaLlama 3.18b instruct. So we'll be using this model along with the keys that we are generating. I have copied my API key. I will just paste it here, and before I paste, I will add it inside a get pass. From get pass, import get pass. Here I'll just write get pass, enter API key. I will just paste my API key. That's it. As I said earlier, by default, OpenAI is the default LLM. We need to override it with the existing LLM that we are using. And the LLM that we are using is SambaNova systems. So let's write that code. Inference SambaNova systems. So the first line is from LlamaIndex dot LLMs dot SambaNova systems. I need to import SambaNova cloud. And now I'll be using settings so that I can override the default LLM from LlamaIndex dot core import. It should be settings. Now let's define LLM equals to SambaNova cloud, SambaNova cloud, and then I need to define model equals to, you can just come back to your cloud.SambaNova AI. Here is where you have the model name. Copy this model name, paste it here, and the second thing is you have context window. As per documentation, the context window that was used in LlamaIndex documentation was 100,000. And then we can define the temperature. Since I need it to be creative, I'll keep it more than 0.5. Let's keep it 0.7. Then we have maximum tokens. Max tokens equals to 1024. We can also keep 2000. And then we have top p value. Top p value we can keep 0.01. And then we can keep top k to be 1. So let's run this. Alright, in order to create the inference, I'll just use llm.complete, and I'll just write a simple user question. I'll ask, what is the meaning of life? So as you can see, you have the response, and it is so quick. It generated this much detailed response in just less than 1 second. It's so cool and it's so fast. Now what we will do is, we will override the settings dot llm. Let me check for autocomplete. It's LLM equals to LLM. Alright, so two steps are completed. The first step is setting up the environment variable. Second step is overriding the default LLM. The third step is we need to define our function calling tool. Function calling tool, that is duck, go. In the second video of our agent playlist series, we defined React agent. During that video, we used DuckDuckGo as a search tool. We'll use the same code that we have used there, and I'll explain you what we did. So let me quickly copy paste the code so that we understand what is happening behind the scene. So this is the code that we had used. From DuckDuckGo, we will import ddgs, which is nothing but DuckDuckGo search, and then we have from LlamaIndex.core.tools, you are importing function tool. So function tool is where you are giving the tool to the LLM so that it can generate the response by doing real-time search. So these are the two libraries that we need to use. Let me add this in different cell. And now you need to define the function. Two things you need to define in the function. The first thing is the data type. You should always have the data type whenever you are defining a function. In our case, it is string. And then you need to define the docstring when you need to use this tool. In our case, we need to use this tool for search results to the given user query. So this is the context and this is the format. Docstring is very, very important when you are defining the agent for the tool, of course. So if you use this kind of function calling, I have just added the comment, never use this. Don't use function calling with this syntax. So don't use this syntax. Here there is no data type defined. You need to define this data type and you need to have a doc string. So now let's proceed by defining DuckDuckGo search, and then whenever a new user query is asked, you need to create .text and add the user query, and then maximum result is 4. So what is max result? Whenever a user query is asked to DuckDuckGo, how many search results it needs to generate? 1, 2, 3, 4, 10. So you need to define that max results, and then it will generate you a JSON file which will have description, URL, other metadata. The only thing what we need is the body. So what we will do is we will run over a loop. So this response over here has 4 elements. So when you run this, right, you are getting 4 elements. 4 elements. You have to run in a loop, get the body from all the 4 elements, and then add it inside a context variable. So this is how you define your function calling tool, and then use search tool equals to function tool dot from defaults. This is a LlamaIndex function, and then you need to define your function, that is search, the same name, that's it. So this is how you define the function tool. Let me run this. And now comes the final part, that is to define the LATS agent. From LlamaIndex dot agent dot LATS, you need to import LATS agent worker. So this is how you import LATS agent worker. And the next thing is, since we are using LlamaIndex, it's a best practice to use agent runner whenever you are using a worker. From LlamaIndex dot core dot agent, you need to import agent runner. You have agent runner. So these are the two import that you need to define. And now we will define the agent worker. For agent worker, we have LATS agent worker. Now let's understand what are we supposed to pass. The two things that we need to pass is the search that we have and the LLM that we have. So let's define that. You have LLM equals to LLM. Then you have tools. Inside tools, it should be within list. Make sure it is within list. You have the search tool, and then verbose to be true. Now there are two additional parameters that we need to define. If you check out our diagram that we created, based on the user question, you have a root node. That root node is creating an expansion node. So you need to define how many expansion node you need. So in our case, I'll define number of expansion to be 2, because if you have more expansion, probably it will take more time. So it's better to limit between 4 to 5, but for this video I'm just using 2. And next we have something called as maximum rollout. Maximum rollout is nothing but in how many loops it needs to run. So I'll just define max rollouts. Let me check for the autocomplete. Max rollout equals to, again I'll keep 2. You can keep it -1 for unlimited number of running, but I don't need unlimited run, so I'll just keep 2 or 3. So this is good. We have the LLM, we have the tool. Verbose is true so that I can show you what is happening behind. And then maximum expansion is to create number of nodes. Then we have maximum rollout, which is 2 as well. Alright, so we defined the worker, and the next thing is you need to define the agent. Agent equals to agent runner. Inside agent runner, you just have to define the agent worker. That's it. Alright, so you are able to create your agent. Now the next step is you need to execute this agent, and in order to execute the agent, you need the user query. Execute the agent, and in order to execute the agent, just write a user query. And I want to build a recommendation engine. So what I'll do is I'll just tell looking for a mirrorless camera under $2,000 with good low light performance. Give top 5 suggestions or recommendation. So this is the user query that I'll be using. And now before we can proceed to executing this particular response or agent, we need to consider two things. There are high chances when you run agent.chat and this user query, you might get I'm still thinking In that case, what are we supposed to do? So during that time, what you can do is you can get all the list of the tasks, get the final observation, and then append it to the user. So we can do that thing. But if in case you get the response from agent itself, then we are good. So let's try it out. I'll just use agent, not agent, it should be response equals to agent dot chat, and I will give the user query that I defined. So I just have to pass this query. So it's creating the responses. As you can see, you have root node, and inside that root node you have multiple expansion. So this is the first expansion, consider Sony Alpha. So this is the first expansion or node, and then you have the second node. So these are the two nodes that is being created, and then you have thought, action, observation. So let me show that as well. You have thought, this is the thought, you have action, and then you have observation. It's again repeating it. You have thought, action, observation. This is for another node, and then it is evaluating. I already showed you how it evaluates using the formula where you are using LLM as a value function, and then it will generate the response. So if you look at the final response, this is what I was talking about. In most of the cases, when it is related to language agent research, you will encounter the same response saying, I'm still thinking. So in that case, you can get the final observation and show it to the user. So again, it will run the loop just to see if you are getting the response or not. And here again, it's still, I'm still thinking. Again, it's running. Again, it is telling, I'm still thinking. So this is where LATS is using Monte Carlo Tree Search. It needs enough information. And this is one of the drawback of language agent research. That is, it's very complex. It is very expensive, and it takes too much of time to generate the response. So when should you use LATS? You should use LATS when you have very complex query and you don't have any latency issue. That is where you can use LATS by increasing the maximum rollout, and you can increase the maximum number of expansion. And then what you can do is you can append the final observation. So let me show you how to append that. Error and link and Hacky approach. So let me show you how it is done. But before that, let us check the response. Response.response. It is I'm still thinking for sure. It says I'm still thinking. Now what you can do is you can define a function. If it is response.response equals to, sorry, it should be like this. If I'm still thinking in response.response, you need to have a function here, or you need to have some logic, right? Let's write this logic first. Let me write this logic. So in order to get the observation, the first thing is you need to list down all the tasks that you have. So what I'll do is I'll just write agent dot list tasks. So this will return a very big response. It is from all the expansion and all the observation that it has created. So as you can see, it's a very big response. So what I need to do is I need to get the second response. So I'll just write -1. It should be -1. Again, as you can see, you have a very big response. I'll show you what we need. Once you give -1, the next step is you need to define something called as extra state. So once I define this extra state, you will see the observation here. So let me show you the results. So when I use extra state, you have count to be 2, and here is where you have the observation reasoning step. So how do we get this observation reasoning step? Let me check all the keys first. Let me check all the keys. So as you can see, you have count, you have solution queue, you have root node, you have sources, and you have memory. So what I need now is I need the root node. So let me get this root node, remove the keys, add root node over here. Let me again scroll up. You have the search node. Inside that you have current reasoning, and we need this observation reasoning step where you have the observation. So now what we will do is we need to get the children. So there will be a children node. As you can see, you have the children node. Copy this children 0. Again, you have to run the same step, children 0. Since I used maximum rollout to be 2, I'll use children 0 for 2 times, and then I will use the reasoning. Current reasoning. What is the current reasoning that it does? Now if I print this, you have, this is your output. This is the output that it had generated. Now what I'll do is I will just take all these details and I will add it inside the context. Okay. So now what we'll do is from observation in context, you need to get all the observation. What you need to do is you need to get all the observation dot observation. So you only need to get observation dot observation. If there is any thought and action, you just have to remove it. So what we will do is I'll just write a try and except block, try, and then you can have except block, print. I'll just write pass. So what we can do is instead of printing it entire thing, we can use this inside a dummy variable. For dummy variable, I'll keep results. Now what I can do is I'll just write result plus equals to observation dot observation. So now if I print the result, this is my context. Okay. Now what I'll do is I will take the context, I will take the user query, and then I will append when I have the response saying I'm still thinking. So now what we will do is we will use an LLM as final response equals to LLM dot complete. Here let's write a prompt. We will write a prompt, and the prompt is for the given user query you have required context. Use the context and generate a reasonable response back to the user. And then what you can do is you can just pass user query and context equals to context. And what I'll do is I'll make it as f string since I'm not using any template. So user query is nothing but the query that you had, and context is nothing but the result that you generated. That's it. So if I am still thinking is my final response, I just have to create a prompt, give the final response, and then just print final response. And there you go, you have the response. As you can see, based on the requirements for the mirrorless camera under $2,000 with low light performance, here are the 5 recommendations. So you have the 5 recommendations which were generated, and this is the Hacky approach. If in case you get I'm still thinking, you can go ahead, have a prompt that will append all the observation and the user query, and it will generate the response. So this way you don't have to spend too much of time in generating and gathering the information from LATS. You can run it for some experimentation. Max number of expansion can be 5. Max rollout can be around 5 to 6. And once the entire execution is done, if you still get I'm still thinking, then you can take this approach. If not, you can keep response.response to be true. So I'll also show you one of the other implementation that I had. Here, when I ask the same question and the same query, if you see, my final response as the actual response. When I run response.response, I do have the same response. But the thing is, I ran this 3 times to get this response. It's still a research area. It can't be used in your POC or production grade system. It's a very expensive approach. It's good for research. But if you want to implement agent in your production system, React agent is one of the efficient method. But in terms of performance and complexity, you can use LATS, but it's still not recommended. This is just a research-based experimentation that we had to conduct because as per the paper, there were lots of benchmarking that LATS had performed, and we just wanted to experiment. I hope you found this video insightful.
There are so many videos on agent coming soon, and stay tuned for more videos.